Our next topic is recursion. This is very important topic because a lot of functions or the procedures can be written using recursion. That is, they can be written as recursive functions. So let us learn about them. So what are the topics that I am going to cover in this video? What is recursion? Example I will take and explain by tracing of that recursion, how to trace it, how to know the output of a recursion. Then a recursion uses stack. So what does it mean? How it uses a stack? That I am going to explain you. Then also I'll show you how to find the time complexity of any recursive function. So let us start with what is recursion. Now before showing you recursion, first of all let me remind you one thing. Here I have one example program, that is main function, and one more function called function fun. And this main function is calling this function. So how this function call is made, how it works, let me remind you this. Already I have explained you in my previous video. Let us look at it again. See, once I start executing my program, it will start executing from main function. First it will execute the first statement, then second statement, then the third statement is function call. It goes to this function, enters inside, execute first statement, second and third statement. Once it has finished, the function ends and the control come back to the same line, that is third line. If any more operations present in this line, they will execute. Otherwise, it will execute fourth line and fifth line. What does it mean by any other operations? For example, this function is returning something, and here I have written multiplied by 2 something. So the value of that function has to be multiplied by 2. So this multiplication will be done once the function has returned here with some value. Assume that that function has returned 10. So 10 into 2 can be done only if this function has returned the result. So once again quickly, program starts, first line, second line, third line, control goes here, first, second, third, function ends, control returns, anything pending that will be done, and then remaining statements. This is the important point that you should remember for understanding recursions. So let me explain you next about recursion. Let us look at a general form of recursion. So here I have an example. This is a recursive function. So what does it mean by recursive function? A function is calling itself. So if a function is calling itself, then it is called as a recursive function. So a function, inside that if you see, it is calling itself again. So this is a recursive function. Then one important thing inside recursion is, here you can see that this is a base condition. Condition is there. So there must be some base condition that will terminate recursion. There must be some method to terminate this one. Otherwise it will go into infinite calling. It is just like this. First we call the function first time, then it will call itself, again call itself, again it call itself. So repeatedly it will be calling again and again. So there must be some condition at which it must stop. So in this example, this will call itself if the condition is true, or it can stop if the condition is true. Whatever it is, at some point it must stop. So here if the condition becomes false, it will not call further and it stops. So finally, let us look at it again. A function calling itself is called as recursion, and inside recursive function there must be some condition which will make the recursion stop, terminate. So in my example, if the condition becomes false, it will stop. That's it. So let us take some example of recursive function and study how it works. Let us look at an example. Let me explain you the example. I have a main function which is having some value and calling function fun1 by passing that x, and function fun1 taking parameter n, and if the condition is true, it is printing and then calling itself. I have used a C language code here. So it's printing and again calling itself for a reduced value of n. If whatever n is, suppose n is a 5, then it will call itself for 4. So if I am passing 3 from here, what will be the result? How it works? Let us trace this recursive function and check. Now tracing. How to trace a recursive function? Recursive functions are traced in the form of a tree. So let me start tracing this one. See, inside the function there are two steps that it has to perform if this condition is true. First step it has to print, second step it has to call itself by passing n minus 1, and this it has to do only if n is greater than 0. Let us start. From here I am calling function fun1 by passing x, that is value 3. So here fun1 by passing 3. So first time it has got 3. 3 is greater than 0. Yes. First step, print n. So first step is print 3. Then what is the second step? Call itself again fun1 for 3 minus 1, that is 2. So it will call itself again by passing fun of 2. See, inside the function there were two steps. Both the steps I have completed. First step was printing and the second step is call. So printing is nothing but the output. So what is the output I got so far? Output is 3. Then what about this? It's a call again. Whether this call has finished? No, it has completed first line, second line. It has not yet came out of the function. It has not yet came out of the function. It has to come out. But it is calling this one. So let us execute this. Fun of 2. Again start. 2. 2 is greater than 0. Yes, 2 steps. So the first step is print 2. So the output 2. Then call itself for n minus 1. So fun of 1. Now still this call has not finished. It has printed and it has to call this one. So again a new call, fresh call. Again a fresh call. So that fresh call is fun1 with 1. So fun1 with 1. 1 is greater than 0. Yes. So perform two things. First step, print 1. So in output we get 1. Then the second thing is call for 1 minus 1. So fun1 of 1 minus 1 is 0. Now fun0. Fun1 of 0, n, that is 0. Greater than 0? No, it is not greater than 0. It will not enter inside, so it will not perform these two steps. And it does nothing. So no printing and no calling, and it will not enter inside, and it will come out of the function. So this call doesn't do anything. So there is no further calling. Then what it has to do? It will go back to the previous function and come out of the function. So this function finishes. It go back to the previous function that is in this line and come out. Afterwards there is nothing remaining, so it will simply come out and go back to this function and comes out of this one. Then it will come back to main and terminates. So from this call it goes back to the previous call and then previous call, just like the way just now I have shown you how a function terminates and it goes back to the place from where it was called. So this is a tree, and this is called as tracing tree of recursive function, and this is the output. Now I will take one more example and show you. So this example I'll just move it aside, then I'll use this portion for showing you next example. Now I have one more example of a recursive function. This is more similar to the first one. Let me compare them and show you. If you check the main function having variable x and calling function fun1, here also main having variable x and calling function fun2. Inside fun1, it is taking parameter n and n greater than 0, two things are done. Here also taking parameter n greater than 0, two things are done. But the difference is, here it is printing and then calling itself. But here, first it is calling itself, then printing. Then what will be the output? So let us trace this one. So this is a minor difference between these two functions. Let us trace. So from here I start. First main function is calling this function fun2. So by passing value 3. So first time function fun2 will be, this is 3. 3, n is 3, so 3 is greater than 0. Yes. So first statement is what? Call itself for n minus 1. Second statement is print. So first statement, it will call itself for fun2 of 2. N is 3, so 3 minus 1, 2. Then what about the next statement, printing? It will not be done. First